Hiya, we're going to look at metallic bonding and then we're hopefully going to be able to explain some of the characteristics of metals that we know about already. Now, some of these characteristics are that they tend to be solid, they are hard, they conduct both heat and electrical energy, they're malleable and ductile. It's just mean these last two just means that they can be shaped, molded, dented, drawn into wires. Um, but we also need to think about why they can do this. So why do metals look and act in this way? Well, it all comes down to how the metal atoms are bonded to each other. And then in looking at the bonding, it actually all comes down to electrons. Now, whether we're talking about ionic, covalent, or metallic bonding, it all comes down to what the electrons are doing. Now, one way we can think about this is if you've ever been to a stadium, some sort of sporting event, you might have seen a few beach balls being taken around, and then they get thrown in the stadium and they all get bounced around and it's all kind of random and everything. Well, that's fine, but in terms of electrons, let's imagine that everybody brings, well, at least one beach ball because um, all metals have at least one valence electron, one outer electron. And then in the stadium, these might all get moved around randomly. And this is kind of how electrons move in a metal. Okay, they're free to move wherever they want in the metal, and that's unique to metals. We've never seen this before in anything we've looked at up to this point. So um, that's fine. So just imagine though you were on, and let's move these around a little bit here. But imagine you were on the field and you looked up. Now it might look, if you were on the field, it might look like it's just a sea of beach balls. Okay. Now in terms of metallic bonding, what we actually look at is this sea of electrons. Okay. Now we have um, this picture here, and that's all fine. But we've got our metal cations, okay, and they're just these kind of pinky red balls there. And then we've got our electrons, and the electrons here are classified as delocalized. Okay, and then if we look at how these might move around in here, okay, that electron can move anywhere around here. Okay, so it's delocalized. It's not actually tied to any particular atom. Okay, so although these are cations, okay, and the electrons are attracted to them, well, they're attracted to this one, and they're attracted to this one, and they're attracted to that one, and they can just move around all around. Okay, so how does this actually help us understand some of their properties? Well, if we look at a simple one first, so if we take a battery, then the electricity or the electrical charge is it's all about flowing electrons. Okay, so flowing charge I'm going to put here. Now our charge, the electrons carry a charge. And we would have, if we connected this battery up in some sort of circuit, we would get a flow of charge from our negative end all the way around to our positive. Okay, and I think we understand that. Now, what we can do is we can go back and have a look at our stadium and our beach balls scenario. But what might actually happen here is we might actually have a gust of wind, and that gust of wind would blow each of these beach balls in this direction. Okay, in one direction only, because in our battery the electrons only flow in one direction. Well, with our gust of wind, they also only move in one direction. However, what's slightly different then about the electrical circuit is that you get the continual flow of electrons. So this would come back round and then it would join the beginning. This would come back round and join the beginning. This would come back round and join the beginning again. So in this way, we never actually lose our beach balls out of the stadium. So we've got that idea that this would then allow us to conduct electricity, and it's actually this same kind of reasoning that allows us to conduct heat as well. One other thing that we could do is if we were to bash the side of our metal, we would dent it, we can shape it, and what we do is, because we've got this sea of electrons, it kind of acts like a little bit like a slippery plate, where if you can imagine then that the electrons here just allow the ions to slide past each other just a little bit. Not much, otherwise you will end up breaking the metal, but it's just enough that we can dent it without breaking it. Okay, and in that way we can classify the metal as malleable. So there we go. We've had a very quick look at metallic bonding and some of the reasons why metallic bonding enables us to talk about some of the metal properties. And it all comes down to this idea that we've got this sea of electrons, that we've got metal cations and completely delocalized electrons, which is unique among the bonding that we've looked at so far. So there we go.